Let us test this one. Here you have the summation of n factorial to power n divided by n to power 4n. N starts from 1, goes to infinity, and we want to check the convergence and divergence of this series. Because of this exponent n here and down here, I'm going to use root test. For the root test, remember that we find the limit of the nth root of the absolute value of an as n goes to infinity, and the behavior is the same as the ratio test. If L is less than 1, you're going to say that, hey, the series an is convergent. Series, if L is more than 1, you have a divergent series. And if L is equal to 1, it is inconclusive. The test doesn't work here. Very good. So let us begin. We are finding the limit of the nth root of absolute value. Absolute value, you don't have any negative numbers here. So you can basically get rid of absolute value. N factorial to power n divided by n to power 4n as n goes to infinity. Well, what's the meaning of this? It means that you're finding the limit of, here you have n factorial to power n divided by n to power 4n raised to power 1 over n. Or basically, you can separate this if you want to see more detail. Here you have the limit of n factorial to power n raised to power 1 over n divided by n to power 4n raised to power 1 over n. Now you can easily cancel out n and n, and n goes to infinity in this limit. So what do we see here? We have the limit of n factorial divided by n to power 4 as n goes to infinity. But the numerator goes to infinity much faster than the denominator. N factorial goes to infinity much faster than n to the 4th. So what's the meaning of that? You can break this guy down into smaller pieces if you feel more comfortable, or you can basically take a look at the speed of these quantities. This guy can also be written as the limit of n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial divided by n to power 4 is n times n times n times n, right? And n goes to infinity. So first of all, you can get rid of these two. And the limit of n minus 1 divided by n as n goes to infinity is equal to 1. The limit of n minus 2 divided by n as n goes to infinity is equal to 1. The limit of n minus 3 divided by n as n goes to infinity is equal to 1. And you're left with the limit of just one quantity here. The limit of n minus 4 factorial as n goes to infinity, which goes to infinity, all right? So since this guy goes to infinity, it means that the series is a divergent series. Since the limit of the nth root of absolute value of an as n goes to infinity, it means that the series is a divergent series. It means that if you add the terms of this series together, it doesn't go to one unique number. It gets larger and larger. It means that the summation of n factorial to power n divided by what was on the denominator, n to 4n, and start from 1 goes to infinity, which can be written as 1 factorial to power 1 divided by 1 to power 4 times 1 plus 2 factorial to power 2 divided by 2 to power 4 times 2, plus you can add these terms together, right? This sum goes to a, it doesn't go, let me write it this way. Does not add up to a finite unique number. It gets larger and larger in size. So in summary, what do we have? We have the series of n factorial to power n divided by n to power 4n. Because of n on the exponent, I want to use the root test. This is my first attempt. My root test says, hey, as long as the limit of the nth root of the absolute value of an as n goes to infinity goes to a number, and that number is less than 1, you end up with a convergence series. If that value is anything more than 1, then it is a divergence series. If it's equal to 1, then this test doesn't work. You have to move on to a different test. In finding the limit of the nth root of this quantity, nth root, it means that you're raising everything to power 1 over n. So simplifying this fraction, you end up with the limit of n factorial divided by n to power 4. N goes to infinity. Intuitively, n factorial goes to infinity much faster than n to power 4. Algebraically, n factorial can be written as n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial. On the denominator, you are multiplying n by itself 4 times because n to power 4. But you can cancel out n, and the limit of n minus 1 divided by n as n goes to infinity is 1. The limit of n minus 2 divided by n as n goes to infinity is 1. The same for n minus 3 divided by n as n goes to infinity. This limit is also 1. So you end up with the limit of n minus 4 factorial as n goes to infinity, which is nothing but infinity. What's the meaning of that? It means that by applying the root test, we end up with a divergent series. This sum doesn't add up to a finite unique number. It gets larger and larger in size.